Okay, so in this section, we have rational equations that we're trying to solve. And anytime we have equations with fractions, I think the easiest way to deal with that is to figure out a way to just get rid of those fractions. So what we're going to do in this section is we are going to clear the fractions by multiplying by the least common denominator. And we've seen the least common denominator for a few sections now, so hopefully we feel fairly confident in finding what the heck the least common denominator is. Then we're going to show how to get rid of those fractions by multiplying by the least common denominator. We'll be left with some type of equation to solve, maybe just a regular old linear equation, maybe a quadratic that has an x squared in it. And then one thing we are going to have to do is I'm going to put a little star right here. We're going to have to check the solutions. And the reason we have to check the solutions is we know that we cannot have a 0 in our denominator. So if we have a variable in the denominator, whatever we get for our x, we have to make sure, okay, if I plug that back into my equation, am I going to get a 0 in the denominator anywhere? So, like for example, 366, we don't have to worry about that because our denominator does not have an x in it or a variable in it. On all the rest of them, we are going to have to check our solutions at the end because our denominator cannot equal 0. Okay, so looking at this one, our first step is always to just find our least common denominator. We've got a 3, a 6, and a 4. So we're thinking about what the common multiple, if we're counting by those numbers, 3, 6, 9, 12, 6, 12, 18, 24, 4, 8, 12, 16. Well, the least common denominator is going to be 12. Okay, so we're going to multiply every piece of this, and it's going to look a little bit messy here. We're going to multiply every piece of this by 12. All right, so here, and there's a couple ways to do this. If you want, we could just say, okay, 2 times 12 is 24, divided by 3 gives me 8, so we've got 8x. You could also simplify first and say, okay, 12 and 6 can both be divided by 6. I'm left with a 2. Well, 5 times 2 is 10. Equals, okay, that 4 and that 12 will cancel out. I have a 3 on top, equals 9. So now look, we're left with a much simpler equation that we can solve, and we don't have to even think about those fractions. So that's what multiplying by the least common denominator does, is it clears those fractions. It gets rid of those fractions. So now if we solve this, we add 10. We get 8x equals 19 if I divide by 8. X equals 19/8. That fraction cannot be simplified. So that's kind of the basis of this. Mostly what we're going to be working with are things that have maybe binomials in the denominator, maybe a trinomial in the denominator, but this gives us kind of a basic picture of what we're doing, finding the least common denominator. Okay, so let's look at example 367. I'm going to highlight my denominators. I only have 2 of them. And they're the same, so that makes it really easy. So our least common denominator is just going to be that x plus 2. All right, so to get rid of those, we're going to multiply. Again, one thing you do have to remember here is we're going to multiply every piece by that least common denominator, by an x plus 2. And let's see why that helps us. Well, we have an x plus 2 on top and x plus 2 on bottom. Those cancel. So I'm just left with 5x plus 5. Here we don't have anything to cancel with this with on bottom, so we're just going to have to multiply these. 3x times x is 3x squared. 3x times 2 is 6x. Here we have this on bottom, this on top. Those cancel. We just have equals x squared on top. All right, we are left with a quadratic on this one, so we're going to move everything to one side. so that my quadratic is set equal to 0. And as I combine these like terms, I'm going to go ahead and write it in standard form with my x squareds, then my x's, then my numbers equals 0. So I have 2x squared, put our x's together, plus 11x. We have plus 5 equals 0. All right, we've got to think about how we factor this. We have a quadratic trinomial with a number in front that we can't take out. So we're going to have to multiply our a by our c and factor by grouping. I'm going to just come over to the side and do this over here, just so that it doesn't get quite as messy over there. So 2 times 5 is 10. I want two numbers that multiply to give me 10, add to give me 11. Well, we have 10 and 1. So I have 2x squared plus 10x plus 1x plus 5 equals 0. We group it, take out a 2x, we're left with x plus 5. Take out a 1, we're left with x plus 5. So my two factors are going to be 2x plus 1 and x plus 5. All right, so if we solve these, we're going to take each one, set it equal to 0. So we get x equals negative 1/2 if we solve that, and x equals negative 5. So those are my two solutions. We can even just kind of do this mentally and make sure if we plug these back into our original equation, if we plug them back in for this right here and this right here, that we don't get 0. Well, negative 1/2 plus 2 is not 0, and negative 5 plus 2 is not 0. So that one works, that one works. So I'm going to write here, both solutions work. Okay, so now let's get one that's a little bit more complicated here. First of all, before we do anything, let's decide what our least common denominator is. So up here, I'm going to say, all right, my least common denominator, let's look at all of our denominators. This is the x plus 2, an x plus 1. This one has an x plus 1 and an x plus 2. So our least common denominator is going to have to be x plus 1 and x plus 2. All right, so we're going to multiply every piece here, right small, because this gets messy. This piece, and this piece by x plus 1 times x plus 2. X plus 1 times x plus 2. X plus 1 times x plus 2. Okay, and let's see how that helps me, how that helps clear these fractions. Well, this x plus 2 and this x plus 2 cancel. I can go ahead and multiply these two things on top, and I get x squared plus 1x. This x plus 1 and this x plus 1 cancel. We can multiply what's on top, and we get plus 1x plus 2. And then here, this x plus 1 cancels with this x plus 2 cancels with this, so we just have equals 5. So again, a really complicated looking equation turned into something fairly simple once we got rid of the denominators. So we do have a quadratic, so let's move everything to one side and see if we can factor. I'm going to move the 5 over. I'm going to go ahead and combine these, so I get x squared plus 2x minus 3 equals 0. All right, to factor this quadratic, we want to think of two numbers that multiply to give me this, add to give me this. We're going to have x plus 3 and x minus 1. So my two solutions are going to be x equals negative 3 and x equals positive 1. And again, let's kind of mentally check. Let's think, okay, if we plug those into our x's here, do we ever get 0 in the denominator? Well, in this case, we don't. Both of these solutions work, so they're both part of our answer. All right, let's look at 369. First thing we have to do is decide what is our least common denominator. To do that, it's going to be a lot more helpful if we factor this thing right here. So if I factor this, two numbers that multiply to give me 2, add to give me negative 3, I'm going to have x minus 2 and x minus 1. So I'm going to just kind of scribble that out. We rewrote it in factored form. which that's kind of nice because this has both factors. This has x minus 2, this has x minus 1. So our least common denominator is going to be x minus 2 times x minus 1. So just like we did above, I'm going to multiply each piece by x minus 2 times x minus 1, x minus 2 times x minus 1, x minus 2 times x minus 1. Okay, so now let's go through, hold on, and cancel what we can. This and this cancel, so I'm left with x squared minus 2x. This and this cancel. Be careful here though, we're distributing, this is a minus 1, so minus 1 times x is negative 1x. Minus 1 times negative 1 is plus 1. Equals both of these are going to cancel with both of those, equals 11. So similar to the one above, we're going to move everything to the left side, see if we can factor. So I get x squared minus 3x minus 10 equals 0. Two numbers that multiply to give me negative 10 add to give me negative 3. We have x minus 5 and x plus 2. So our two solutions are positive 5 and negative 2. And again, come back up here and just look at your original equation. If we plug either one of those numbers in for my x's, do we get 0 in the denominator? In this case, no. So both of my solutions work. All right, this last one here. This one's kind of a doozy, so stick with me. I'm going to work through all the steps with you. It's a long process, but each individual step is not that difficult. We just kind of have to think through what are our steps to solve this. So the first thing we have to do is we have to find our least common denominator. Okay, so let's look at the denominators we have. We have x minus 3, we have x plus 2, and we have 8. So they have nothing similar, nothing in common. So our least common denominator is going to have to include all those. It's going to have to include the 8. I'm going to put that in the front just because you usually see your numbers in front. It's going to have to include the x minus 3, and it's going to have to include the x plus 2. Okay, so this is a lot to multiply. So I'm going to write small. We have to multiply all these pieces by that. We're going to multiply this by 8 times x minus 3 times x plus 2. Multiply by 8 times x minus 3 times x plus 2. Multiply by 8 times x minus 3 times x plus 2. Okay, let's see what cancels. This and this cancel. So I'm left with, I'm going to go ahead and write it out and then we'll do the multiplication. So I'm really left with 8. I still have that x plus 2 and I still have this x minus 2. So I still have this, still have this. Okay, our second one, we have a minus. Don't forget that minus there. These cancel. So I have minus 8. I still have this. I still have this. X plus 2. X minus 3. Here, my 8's cancel, but I'm still left with equals 5 times x minus 3 times x plus 2. Okay, we have a lot of multiplication to do here. And you can kind of do this in either order. What I'm going to do is go ahead and multiply my binomials, the things that I underlined, and then afterwards I'll distribute the number out in front of them. So I'm just going to leave that 8 there for a second. If we distribute this, and you could come over here to this side and do it, just for time, I'm going to go ahead and multiply it. We get x squared minus 2x plus 2x minus 4. Well, those 2x's in the middle are going to cancel, and we get x squared minus 4. Okay, our second one, if I multiply these, I get x squared minus 3x plus 2x minus 6. If we combine like terms, we get x squared minus 1x minus 6. And then our last one, if we distribute this, x squared plus 2x minus 3x minus 6. It's actually the same one we just did. We should get x squared minus 1x minus 6. Okay, we have some more multiplication to do. I'm going to distribute those coefficients out in front. So we get 8x squared minus 32 minus 8x squared plus 8x plus 48 equals 5x squared minus 5x minus 30. All right, let's see what we can combine. This 8x squared minus this cancels. So I'm going to go ahead and move everything. Since my x squared's over here, let's move everything to the right side. So I'm going to do a minus 8x. I'm going to do a plus 32 and a minus 48. All right, let's see what we get here. So we have a 0. I'm going to scoot up here. We have a 0 on the left side. We just have a 5x squared, nothing to combine that with. Negative 5x minus 8x is negative 13x. And then we have negative 30 plus 32, which gives me 2. 2 minus 48 is negative 46. Okay, so now we've done most of the work, but we still need to go ahead and factor this. So when we factor this, you can factor by grouping, or some of you are getting pretty good at kind of guessing and checking here. So we can think about it this way. To get 5x squared, I have to have a 5x and a 1x. There's no other options. That's the only way we can get to 5x squared. So now if we think about what these can be, all right, we need to think of ways that we can multiply to give us negative 46. We could do negative 46 and 1. We could do negative 23 and 2. So let's just kind of guess and check here. I'm going to say, all right, let's do a minus 23 and let's do a positive 2. So if we think through that, okay, 5x times 1x is 5x squared. That gives me plus 10x minus 23x minus 46. If we combine those, we do get what we originally started with, so we know those factors are correct. And again, you could do this factor by grouping like we normally do, but if you're getting pretty proficient and kind of guessing and checking what those factors can be, that's great. So if we solve these, our first solution, if we set this equal to 0 and solve, we get x equals 23/5. And our other one, we get x equals negative 2. Okay, don't forget, after we've done all that work, we do have to check our answers here. We do have to make sure that if we plug these in, we're not going to get 0. Well, for sure, if I plug this in, I'm not going to get 0. But if you think about negative 2, if I plug in negative 2 in here for this x, negative 2 plus 2 is 0. So that doesn't work, because if we plug it into our original equation, we have 0 in the denominator, and that's not possible. We cannot have that. So that's one of our excluded values.